Hello everyone, welcome to my channel Middleware Technologies. Today actually we are going to look at the C program compilation steps. Okay, so here in this article or video we'll be trying to understand what all phases a C program goes through when it is compiled using a compiler. Okay, so that's what we are going to explore more in a bit detail so that we understand what it takes to compile a C program using the compiler that are available. Okay, so I'm working on Fedora 37 workstation uh, with GCC C compiler version 12.2.1. Okay, so let us try to understand what is C programming language. Okay, so C programming language is basically a compiler-based programming language wherein we first write a program using a text editor in a text file with ASCII characters. Okay, so that that program can be understandable by a human when it is read. Okay, but in order for that C program to be executed, we need to transform or translate that human readable data or the ASCII character program into a machine readable code which can be executed by the computer system. So that transformation is carried out by a compilation system, that is C compiler. Okay, and this compilation goes through different processes on the source code or on the file in which the C program has been written. So it transforms that C program into different forms until it is finally converted into a executable binary file which can be triggered using the shell script or using in the shell interpreter. Okay, so let me try to explain you a bit on that one. So here is my simple C program. Okay, so let me go into my shell. So here is my C program that basically prints a hello world message when we execute this program. Okay, so this includes a header file which basically means like we are utilizing a library with a function called printf. So this is the function that we are going to use from this library, standard IO library, which will help us to display our message on the screen. Okay, so this is a very basic C program that we are using to demo what phases C program compilation goes through in order to understand better. Okay, so so this is a C program that we are going to use in this video. Okay, so as I said, like the C program compilation system transforms your source code from a human readable instruction to a machine readable code. Okay, so and this transformation is done using in different phases. Okay, so let us try to see what are the different phases that it transforms. Okay, so as you can see, these are the 4 phases through which your C program goes through, that is preprocessor, compiler, assembler and linker. Okay, so here we are going to explore or go into more detailed understanding of these 4 phases. So let us try to explore these phases in the step-by-step procedure outlined below. Okay, so this is a step 1 wherein we are going to pre-process our C program, that is pre-processing phase. Okay, so what exactly happens in pre-processing phase? So our C program is taken which is an ASCII format right now, like which humans can understand, and this program is modified in such a way that like whatever header files are there in the C program, those header files content is inserted into the C program wherever those header file lines are present. So what exactly I mean is, so let's say like you have a header file included in your program. So in my case, this is the first line wherein I have included #include stdio.h. Okay, so a pre-processing step or preprocessor takes this standard io.header file and inserts that code in this place. So it basically modifies this program and inserts the actual code of the header file into this source code. Okay, so that is what exactly happens in the pre-processing phase. Okay, so how we can actually like pre-process a C program instead of compiling it completely, like instead of like using a GCC compiler and compile it to a executable form, we are going to just pre-process it using the utility. Okay, so for this, so if you go into the GCC help, okay, so let me clear my screen, and if you type GCC help, it will show multiple options. Okay, and here you can see this -e option. It helps in pre-processing our code without actually compiling, assembling or linking. Okay, so this is what exactly we are going to do in this step, that is pre-processing our source code. Okay, so I'm going to use the GCC utility to pre-process my hello.c code using -e option and output that content into hello.i. Okay, so let us pre-process this one, and you can see that now we will be having two files. Okay, so now you can see this file just got created, and if you try to look at the content of this one, so as you can see, it consists of all the stdio.h, the header file declarations. So these are just the declarations which gets inserted into this program, like the C program that we have written. Okay, so you can see these are all declarations that got inserted, and here is our actual source code which we have written. Okay, so this is what exactly happens when we pre-process our C program. Okay, now let us go into our next step, that is compilation phase. Okay, so in this phase, basically what happens is it takes the C program which we have transformed or modified in our step 1, that is pre-processing phase, and it converts that whole program into assembly language code. Okay, so assembly language code is a completely different programming language wherein we use very basic operation steps like add, move. So those kind of operation steps we do using the assembly step on the operands. Okay, so if you're not aware of assembly language program, that is fine. There is no need to understand that as of now. But yes, so assembly language programming is the a language which is more like basically relatable or understandable by the program by the computer system. Okay, but it is still not a complete like what we say, machine level instruction code for the computer to understand. And there is a different there is still one more step that we need to do in order to convert our machine assembly language program also to code, or also to a code which is machine readable. Okay, so that we will go and cover in our next step, but right now let us focus on the compilation step. So here, so we are going to use the GCC utility in order to compile our source code which we generated in our first step, and convert it into a assembly language source code and save it into a file called hello.s. So again, with the same steps, we'll try to understand what is the option that we need to use in order to compile our source code. So as you can see, the -s option helps us in compiling only our source our code without actually assembling or linking. Okay, so we will try to use that in order to compile our, so we are going to compile our hello.i, which is basically a modified C program, and output that contained into hello.s. Okay, so let us generate this one, and now let's see, like we will have the hello.s file gets created, and let us try to read this hello.s file. So as you can see, like here is our actual main function that has been converted into the assembly language code. So as you can see, it basically consists of the operation and the operands on which this operation is being carried out. So it is basically a assembly language code wherein it consists of operations and operands on which that operation is getting carried out. Okay, so this is how, like we can convert our human readable source code that is written in ASCII characters to a code that is understandable by the assembly language tool. Okay, assembly language or assembler tool which can understand this code. Okay, so let me clear my screen and go into my documentation. So we have seen like how we can compile our program using the -s option. Now let us go into our step 3, that is assembly phase. So here basically what is happening is, it in the assembly phase, it takes the assembly language code that we have generated in our step 2 and converts that into a machine level instructions which are understandable by a computer system. Okay, so it basically converts the whole assembly language source code into machine format which is basically not understandable by a human, but it is understandable by a computer system. Okay, so in order to like convert or assemble our like code, assembly language code, we need to use an option. So let us try to explore more on that. So let us try to do GCC help, and here you can see the -c option, which basically helps in compiling and assembling our source code, but it does not link. Okay, it does not do linking. Linking is a step that we will go further in our next step, but for now let us try to use this option and do the assembling of our code, which basically converts that assembly language code into machine readable instructions basically generating an object file. Okay, so here, like, we are going to use the -c option with our assembly language source code, which is available in hello.s, and generate our object file, that is hello.o. And now if you see the hello.star, like, we have the hello.o file get created, but if you try to read this file, it is something which we cannot read by uh, ourselves. Okay, so it is something which machine can understand, but we cannot like interpret it. Okay, so this is how, like, we can do the assembling of our code using the -c option. And now comes the final phase, that is linker phase. So until now, like, we have seen like how we can transform our source code, which is like which is written in human readable format, into a format which only the machine can understand. So until now, like, we have finally generated our hello.ho object file, which is actually the machine readable instructions which can be executed. But in order for this program to be executed, we need to do one more step, that is, uh, initially, like, as if you saw my video, like, initially I have mentioned, like, we have included one header file, that is hash include standard io.h. Okay, so that standard io.h contains only the declaration steps of the printf function that we are going to utilize, but the actual definition of that printf function is written in a different file, that is stdio.c. Okay, so stdio.c file, that is the C program file, contains all the definition, like actual implementation of those declarations which are there in the header file. Okay, so we need to somehow, like, link those definition files, that is stdio.c files executable code, with our hello.o executable code. Okay, so who does that? Okay, so that is where the linker comes into picture. So linker, it takes our source code executable file, that is hello.o, and it tries to link it with the standard library object files. Okay, so in our case, it will try to link our code hello.o with the stdio.o executable object code, which is basically compiled, which is basically gets generated with the same procedure like we have followed, like compilation phase, using the stdio.c file. Okay, so stdio.c file is like basically pre-processed, compiled, like assembled, and it generates that stdio.o file. So these two files, stdio.o and hello.o files, are clubbed together, and it forms an executable file, that is hello. Okay, that file name can be anything, but here we have defined the output as hello, so that will be our executable file, which is the final product of our program that we can execute on our machine to generate our output. Okay, so let us go into our step 5, that is executing our program. So here, like, we have seen, like, we have generated our hello.o program, Okay, and now like in the linker phase, like we are going to generate our linker, the final product, that is executable file. Okay, so now if you see, this output file has been generated. So here, like we are going to run our program through linker, which will actually create our executable file, that is hello. So if you see the output here, now we have the hello program executable file gets created, and this file we can directly run using the shell interpreter, which basically loads that program into the main memory and executes that with the processor. Okay, so as you can see, like we have displayed our hello world output, which is the printf line which we have included in our hello.c program file. So this is how the C program compilation steps are followed when we actually compile our C program. So instead of going through all these steps and generating the pre-processing phase output, the assembly phase output, and the binary output, we can directly do. So let me clear my. We can directly do this step, that is GCC minus GCC hello.c program, whatever we have written, and output it directly to hello. So this will actually do all the steps, that is compiler, that pre-processing, compiling, assembling, and linking phase, which we have done initially. Okay. Okay, so this is how, like we can use the GCC utility in order to understand more about our C program compilation steps, and get a better picture of what exactly goes through in modifying our C source code into a machine readable instruction set. I hope you enjoyed watching this video. Thank you all. Thank you for watching this video, and you guys have a great day.